I'm a scientist that cares about the brain. And what I'm wondering right now is whether what's going on in your brain, would it be the same if instead of looking at me here, you were watching me on the video screen up there? And I think the answer is no. And this issue, this idea of the impact of live versus virtual social interactions has huge implications for how we educate ourselves, for our mental health, and even for our evolution as a species. Let me tell you why I think that. Scientists know that American babies can learn to distinguish the sounds that are important for Mandarin Chinese if and only if they're tutored by live Mandarin speakers, not when they're shown a video of that same person. At the other end of the lifespan, the best thing you and I can do to stave off dementia as we age is to be bilingual. And this is the best protector, better than any pharmaceutical currently on the market, in delaying Alzheimer's, in some studies by as much as 5 years. So language is very powerful, and in a sense, it offers a passport into our brains. But as a neuroscientist, there's a problem. Language is uniquely human, and this makes it very difficult to get at the nuts and bolts of how the brain gives rise to language. Fortunately, subcomponents of language exist in other species, and one of these is vocal learning. And this is our ability to modify the sounds that we make like we do when we're learning to speak. Now, among primates, humans are the only species capable of greatly modifying the sounds that they make. And here in SoCal, another one of our vocal learning friends are dolphins. But again, neither humans or dolphins are very amenable to controlled physiological experimentation. So I study songbirds who have this capacity in spades, and much more so than the typical lab rat. Now, although vocal learning isn't uniquely human, when it goes awry, it can have profound consequences for our sense of well-being and social integration. And that's evident in this video here of a girl describing how she feels about her speech and language disorder.
Well, I think it was terrible because my friends do not understand me a bit.
So she thinks it's terrible, and she's had very intensive speech therapy. She's a member of a remarkable family known as the KE family, half of whom suffer from this severe speech and language disorder. And in 2001, the cause of their deficits, a mutation in a molecule known as FOXP2, was found. Now, FOXP2 is a master control molecule, meaning that it governs the expression of a lot of other molecules, like a conductor directing the diverse musicians to produce a beautiful concert. So FOXP2 really is unique in its direct link to language. A mutation alters its function, alters the way the brain develops, and alters the way we speak. But before you think my story is over, think about this. FOXP2 isn't just in our brains, it's in almost all our body organs. It's in our heart, our liver, our kidneys. So why is it that if a mutation in FOXP2 just causes problems for language? And FOXP2 is in other organisms that we don't think of as vocal learners, like fruit flies who don't sing or speak. So how can FOXP2 have this direct, profound effect on language? And I think part of the answer is that FOXP2 cares about social context. Its levels change in the brain when one vocalizes. But that change depends on who is around, who is in the social scene. And when it changes, so do the levels of all the other genes that it directs, part of its molecular network, much like our social networks that we're familiar with. So I think it's this social sensitivity and the suite of genes that FOXP2 is part of that gives its direct effect on language. And let me tell you how we made these discoveries using a songbird. Birdsong can really tell us a lot about human speech because, like humans, songbirds are vocal learners. Like humans, they learn through social interactions. Like humans, they learn best early in development, using similar brain structures and similar genes. So, for example, early in life, both songbirds and humans enter into a vocal learning phase where they're not vocalizing new sounds, they're just listening to the sounds of those around them. And then later on, they start making their own new sounds, which in humans is called babbling. And both song and speech depend upon being able to hear. Deafness causes both to degrade. Now, songbirds maintain the quality of their vocalizations by engaging in cycles of practice and performance. Performance is when a male songbird sings to a female songbird in order to court her, and practice is when he sings his song alone. Now, those two songs look very much the same, as I'm showing you here on a sonogram with time versus frequency, and they sound the same to us. But a female bird can tell the difference. So we decided to look at FOXP2 in the brain of an adult male songbird. And here I'm showing you snapshots of two bird brains. This bird didn't sing. This bird did. The levels of FOXP2 are shown by how dark it is, so there's lots of FOXP2 here, not so much here. We quantified this in two different ways and came up with similar results. But now look what happens when the bird actually practices song by himself. Something very different happens. FOXP2 levels drop dramatically and precisely in the part of the brain that's responsible for these vocalizations. So though the song looks the same to us and sounds the same, FOXP2 levels in these two conditions are very different, because FOXP2 cares about the social context. And when FOXP2 levels change, so do the levels of all the other molecules that it directs. So songbirds really tell us that our social interactions can affect our brains. And currently, our real interactions are more powerful than the virtual ones. Just like human babies, songbirds don't learn well from tape. And if I have to make a guess, I would say that during an interaction, not only is the person that you're interacting with paying attention to you, but they're paying attention to whether you're paying attention to them. And I think it's this engagement that requires this focus that's the key to our mental health, our educational systems, and even our evolution as a species. Thank you.